Alright, so 10.1 is all about probability. When learning about probability, there's a lot of vocab involved. Also, most of our probability problems are going to be word problems. So looking at the homework, it is like 95% word problems. So don't be scared because it's all word problems. Just take it one step at a time. Look at what it's asking. So first thing we're going to look at is sample spaces. So a probability experiment is an action or trial that has varying results. The possible results of a probability experiment are called outcomes. For instance, when you roll a 6-sided dice, there are 6 possible outcomes. It could be 1, 2, 3, 4, 5, or 6. A collection of one or more outcomes is an event, such as rolling an odd number, and the set of all possible outcomes is called the sample space. So in example 1, we're going to look at how to find a sample space. So remember, sample space is the set of all possible outcomes. So you flip a coin and roll a 6-sided die. How many possible outcomes are there in the sample space? So just looking at flipping the coin, what are 2 possible outcomes we can have when we flip a coin? Heads or tails? So we could have heads, or we could have tails. Now let's say we roll heads the first time, or we flip heads. Now we're rolling a dice. So how many possible outcomes do we have when we roll a dice? 6. It could be 1, 2, 3, 4, 5, or 6. That's just when we flip heads the first time. But we also could flip tails the first time, and then we have 6 possible outcomes there.
Oh, like heads and tails, and then 6 times for tails, 6 times heads.
Right, because one time we could flip a heads and get a 6. That's one possible outcome, heads and a 6. Another time we could say we flipped a coin and got tails and a 2. So that's another possible outcome. So these are all of our possible outcomes. So how many possible outcomes total do we have? 12. Possible outcomes. So the 12 possible outcomes would be heads 1, heads 2, heads 3, heads 4, so on, and then tails 1. So like this is one outcome, this is 2, 3. So we are counting heads and we are counting tails, but it just kind of goes along with the number. You're welcome. Good question. Alright, so let's look at number 1. Again, we are finding the possible outcomes in the sample space and listing the possible outcomes. So if we flip 2 coins, let's say we flip 1 coin. What are 2 possible outcomes for that 1 coin? Heads or tails? Now we flip our second coin. What are 2 possible options for our second coin? Heads or tails? But let's say the first time we flipped heads, then we flipped heads again, or we flipped heads and then we flipped tails, or we could flip tails and heads, or tails and tails. So how many possible outcomes do we have? 4. So it could be heads and heads, heads and tails, tails and heads, or tails and tails. Alright, let's look at number 2. You flip 2 coins and roll a 6-sided die. So if we flip 1 coin, what are 2 possible outcomes? Heads and tails. And then we flip another coin, what are 2 possible outcomes? Heads and tails, and then again heads and tails. And then we roll a 6-sided die. So let's say we got heads the first time, heads the second time, And then we have 6 possible outcomes the next time because it could either be a 1, 2, 3, 4, 5, or 6. Same thing if we got heads and then tails, we have 6 possible outcomes here. 1, 2, 3, 4, 5, or 6. If we got tails the first time and then heads, then we could roll a 1, 2, 3, 4, 5, or 6. And if we flipped tails the first time and tails the second time, we could roll a 1, 2, 3, 4, 5, or 6. So how many possible outcomes do we have here? 24.
Because you have 4 possible coin outcomes and 6 do you multiply the 2?
So if we were to list them all, we would have heads, heads, 1, heads, heads, 2, heads, heads, 3. 4, 5, and 6. We could have heads, tails, 1, heads, tails, 2, heads, tails, 3, 4, 5, and 6. Tails, heads, 1, tails, heads, 2, tails, heads, 3, 4, 5, and 6. Tails, 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 tails. Tails, tails, 1, tails, tails, 2, tails, tails, 3, and so on. So this would be our 24th. A lazy way of writing the 24th, but you guys get it, right?
Yeah.
Okay. All right. Next, we're going to look at theoretical probabilities. So the probability of an event is a measure of the likelihood or chance that the event will occur. Probability is a number from 0 to 1, including 0 and 1, and can be expressed as a decimal, fraction, or percent. So if something has the probability of 1, that would have 100% probability of happening. If something has the probability of 0, it would have a 0% chance of happening. So you can write it as a fraction, a decimal, or a percentage. They all mean the same thing. Okay, we're going to look at the bottom of page 2 because it kind of explains what we're doing at the top. It's just out of order. So the sum of the probabilities of all outcomes in a sample space is 1. So when you know the probability of an event A, you can find the probability of the complement of the event. The complement of the event A consists of all the outcomes that are not in A. So if I said the probability of you being my student next year is 25%. The probability of you not being my student next year would be 1 minus that probability, so 1 minus 0.25, which would be 75%. So that's just what this explains. These are 2 complements of each other. You could either be my student next year or not be my student next year. And these 2 events are complements of each other. So it'd just be 1 minus the probability of it actually happening is the probability of it not happening. So when 2 6-sided dice are rolled, there are 36 possible outcomes as shown. Find the probability of each event. So A says the sum is not 6. So let's find all of our probabilities where the sum actually is 6. So we have this one here where it adds to 6. This one adds to 6. This one adds to 6. This one and this one. Any others that add to 6? No. So the probability that it adds to 6 is how many out of how many? So how many? 5 out of, what are the total possible outcomes? 36. So 5 out of 36 is that it adds to 6. But we're trying to find when it's not 6.
31 out of 36?
Right, and we would do 1 minus the probability that it does add to 6. which would be 36 over 36 minus 5 over 36, which is what, Sandeep? 31 out of 36.
You'd have to show work like that, right?
No. So I understand once you find the 5 that do add to 6, you can just count how many that don't add to 6, right? Which is pretty much what you did. But you could do it either way. So you can count all the ones that are not 6, or you could do 1 minus the ones that are.
Okay.
So just showing you the two different possible ways to do this.
Okay. Thank you.
You're welcome. Alright, so let's look at B. So B says the sum is less than or equal to 9. So let's find all the ones that are less than or equal to 9. So we have this one, this would be 7, so still less than. This is 3, 4, 5, 6, 7, 8. This is 4, 5, 6, 7, 8. The one down here is 9. Are we including it?
Yeah, no.
Yep, because it says less than or equal to 9. So that would be included. We have 5, 6, 7, 8. This one's 9, so we include it. The next one's 10, so it's not included. Then up here we have 6.
Yeah.
Then 7, 8, 9. The two below are bigger than 9, so can't include those. 7, 8, and 9. So instead of counting all the ones that we just circled, we could count how many we did not circle. So that would be 1, 2, 3, 4, 5, 6. So 6 out of 36 is how many are greater than 9, but we're looking for less than or equal to 9. So how can we find what's less than or equal to 9?
You
Subtract 6 from 36. So we do 36 over 36 minus 6 over 36, which would be 30 over 36. And how could we simplify this?
10 over.
What number goes into 30 and 36?
6, I think.
6 goes into both, right? So divide both by 6. So that would be 5 over 6. Perfect. This one's fun because it's geometry. Yay. You throw a dart at the board shown. Your dart is equally likely to hit any point inside the square board. Are you more likely to get 10 points or 0 points? So first thing we're going to do is find the probability that we can get 10 points. So we're going to say probability of 10 points. So we need to find the area of our 10-point circle and compare that to the area of the entire board. Because our probability is always what we want over the total. So to find the probability that we land in the 10-point circle, we're going to find the probability of the 10-point circle in here, what we want, over the probability that it lands on any part of the board. So let's see. What is the radius of our 10-point circle? 3. How do we find the area of the circle?
Half times r.
Pi r squared. So we have pi times 3 squared. What's 3 squared? 9. So our area of the circle, our 10-point circle here, is 9 pi. Now let's find the area of the whole board. So what is, well, how do we find the area of a square? length times width. So what is the length here?
6.
So if this is 3, and this is 3, that would be 9, and 9 is just half of it. So what's the length of the whole thing? Because looking at our picture here, this has a length of 3, this has a length of 3, and this has a length of 3. So all of this has a length of 9. So the whole length of the board here is 18. What about the width? If it's a square, the same thing, 18. So length times width would be 18 times 18. What's 18 times 18? 324. Can we simplify 9 pi over 324? Does anything go into both of them?
Yeah.
9 goes into both. So we're just left with pi on top. And what's 324 divided by 9? 36. Awesome. Which, if we put this into a decimal, this would be 0.0873. So this is our probability of it landing in the 10-point circle. Now we want to find the probability of getting 0 points. So we want to find the area of this part here, the blue shaded part, because all of that is 0 points. So we should find the area of the square and subtract the area of the big circle. What did we say the area of the whole square is? 324. And then let's find the area of this big circle. What is the radius of the big circle?
9.
Perfect, 9. So we have pi times 9 squared. So 324 minus 81 pi. And what's our total area that we're looking at? To find the probability of getting 0 points, what are we going to divide? Because this is the area of the blue shaded part. What's the probability of the whole thing? Remember, it's what we want divided by the total. So what's our total area? 324. So we have 324 minus 81 pi divided by 324. (81) goes into all of these, so we could simplify a bit. We would have 4 minus pi over 4. Just dividing everything by 81. And then if we put 4 minus pi divided by 4 in our calculator, what would we get? 0.215. So what are you more likely to do? Land in the 10 points or land in the 0 points? The 0. 0, because this is bigger, right? Yes. So we're more likely to get 0 points. All right, we're going to do a few from the bottom down here, and then we'll call it a day. So let's look at number 3. You flip a coin and roll a 6-sided die. What is the probability that the coin shows tails and the die shows 4? So let's draw all of our possible outcomes here. We flip a coin, so it's either heads or tails. And then we roll a dice, so we have 1, 2, 3, 4, 5, or 6. Or we could roll tails or flip tails and have 1, 2, 3, 4, 5, and 6. What is our total possible outcomes here? 12. Now, what is the probability that the coin shows tails and the dice shows 4? How many of these do we have that are tails and 4? 1. Just here. Remember, if we were to write this, it would be heads 1, heads 2, heads 3, so on. Tails 1, tails 2, tails 3, tails 4, tails 5, tails 6. So the only one that is tails and 4 is this one here. So how many out of 12? 1. So this is our probability. Alright, let's look at the bottom. So we need to find the probability of the complement of A. So going back to here, we know that the probability of the complement is equal to 1 minus the probability of it actually happening. So for number 4, if our probability of it actually happening is 0.45, the probability of the complement, so the probability of A bar is what it's called, is 1 minus 0.45, which is 0.55. Perfect. Let's look at number 5. So if our probability of it happening is 1/4, how do we find the probability of the complement? Perfect. So 1 minus 1/4. Or 4/4 minus 1/4. Perfect. So what would we get? 3/4. Or 0.75. Same thing. No, it doesn't matter. But if this was a multiple choice test and you only saw like the fraction, just know that this 3/4 is the same thing as 0.75. Alright, let's look at number 6. So if the probability of it actually happening is 1, what's the probability of the complement?
0.
How do you know it's 0?
Because 1 is 100.
So 1 minus 1 would give you 0. Perfect. Seven. Probability of it happening is 0.03. So what's the probability of it not happening? What have we been doing for all of these?
0.97.
1 minus 0.03, which is 0.97. Awesome.
Will we be able to use our calculator?
Yes, you will be able to use your calculator.